Hello everybody, welcome to this channel. I'm Pandas Python. In this tutorial, I'm going to talk about DataFrame. In the first part, I talked about how to create a DataFrame and how to get access to different values of a DataFrame. In this video, I'm going to talk about how to get some statistical value of a DataFrame and how to manipulate a DataFrame. Let's get started. In order to show you the operation on DataFrame, here I use a dataset called iris, which includes the sepal length, sepal width, petal length, as well as petal width of a series of flowers. And we read this data. And in order to take a look at the first few rows, we can use head method. Here the data is a dataset that we have, followed by dot, and we use head method. And we get the first 5 rows of the data set that we have. The first 5 rows are defined by default. If we want to change this one to 3, then we need to specify 3. And in order to get the last few rows, we can use tail method, the same as head method. It will give us the last 5 rows of the data set that we have. Also, we can get the values of the data frame that we have as an array using values attribute. And when we run this, we get the data as an array. We can also get the shape of the data, the dimension of the data frame that we have using the shape attribute. And as you can see, we have 150 rows with 4 columns. We can get some statistical summary of the data set using describe method. Here, the data is the data set that we have, followed by describe method, and then we transpose the result. And for each numerical column of the data set, we can get the number of the data in that column, along with the average value of that column, with a standard deviation, as well as minimum, maximum, first quartile, second quartile, and third quartile of each numerical feature or each numerical column of the data set. We can change the column name of a data frame. If we want to change the name of all columns of a data frame, we need to write the name of the columns in a list and assign it to the data frame name and columns attribute. If we do this for the data frame that we have, as you can see, the column name of all of them has been changed. However, if we want to change only a subset of the column names, then we can use rename method. Here, we use rename, and then want to change the name of the column, then we specify it as a dictionary. Here, we want to change sepal L to be sepal LEN, and sepal W to be changed to sepal width. If we run this, we see the result, and the name of the column has been changed. We can also add and delete columns to a data frame. For example, here we want to add a new column. All of the values we want to assign to be 1. In order to do that, we name the data frame, followed by the name of the column that we want. And when we run this, 1 column has been added to the data frame, and the values are all 1. And if we want to remove a column, we simply use drop method. In the drop method, we specify the name of the column, and we also specify the axis to be equal 1, which stands for the columns. And when we run this, the column 1, which has been added now, is deleted using drop method. If we want to drop more than 1 column, then we have to specify it as a list. Here I also add another column called category, and I use a choice method that chooses one of yes or no to each row of the data frame randomly, and I want to be 50% yes and 50% no. And when we run this and we see the data, one column has been added as category. In this describe method, we saw that we can calculate the minimum, maximum, standard deviation, average of each numerical column. However, we can calculate those values separately. Here, for example, we want to calculate the maximum value of sepal L. Then in order to calculate that one, we use the data frame name and give the column name. Then we use the max method. If we run this, it gives us the maximum value of that column. We can use it in different way like this. And if we want to calculate the maximum of more than one column, we can specify that one as a list. And here we see that we get the maximum value of these two columns. And we can use mode to calculate the mode of a categorical column. And if we use it for the category, we see that the mode is no. We can use value counts to count the frequency of each value in a categorical column. Here we see that no has 80 times been repeated and yes is being repeated 17 times. And we can use unique to find out the unique values of different classes in a column that we have. Here we have yes and no in this column. We can filter out some rows of a data frame using a slicing. It means that we need to select some rows based on their content using Boolean index, which means that we need to write a logical statement about the data frame and evaluate that logical statement on each row. If it is true, then it returns that row. Otherwise, it does not. For example, here we want to have the data frame only for those rows where category is equal yes. So our statement is wherever the data at the column category is yes, bring those rows. And when we run this, we see that all of the rows has category equal yes. Or we want to return the data set where sepal L is bigger than 7.5. So this is the logical statement that we have, and it's run over all rows of the data frame that we have, and whatever it is true means this sepal L is bigger than 7.5, then it returns that row. And when we run it, we see that the sepal L for all rows are bigger than 7.5. It is possible to have multiple statements for filtering. If that is the case, then we have to use logical operator and or not logical operator. Here we use both of the above logical statement, and when we run it, we get the data where the category is yes and sepal L is bigger than 7.5. Another way of slicing of a data frame is using group by. The group by method divides a data frame into different subsets and performs some aggregation or transformation on each subset independently. And the result of each group by itself is a data frame. And when we apply some aggregation, then we get the results for each category or sub data frame. Here, for example, we group by the data frame based on category, and then we apply aggregation function sum. And as we can see, for each category, which we have yes and no, then we calculate the sum for that category. And it is possible to calculate the more than one aggregation function. Here we want to find the minimum, median, and maximum of each column based on the category. Then we use aggregation method. And as we can see here, then we get the result for each column, and we get the minimum, median, and maximum based on different category. It is also possible that apply different aggregation function to different columns. And in order to do that, we use aggregate method, and we specify what aggregation function to be applied to which column. And when we do this, here we want to aggregate sepal L based on minimum and sepal W to get the maximum. And this is the result. We can transform the data using group by method. The difference between aggregation and transformation is that aggregation returns a shorter version of the data, while transformation returns the full data, which is modified. Here, we want to center the data by subtracting the group-wise average of the data. In order to do that, we use group by based on the category and transform the data. And for each row, we calculate the average of each column based on the category, and then we deduct it from the row. The result is this.